Motherboards, chipsets, and buses. Now, as you recall, we said that motherboards were the spinal cord of the computer, meaning that it's the thing that allows everything to communicate together, and it's what connects all the different parts of the computer together. So as you can imagine, it's a pretty complex and complicated piece of equipment. So before we can discuss how to install motherboards or how to even plug things into motherboards, we need to talk about some of the infrastructure of a motherboard itself and the architecture of it. So some of the things I'm going to talk about in this video are the vocabulary that we're going to see come up again when we talk about motherboards, and three words that we'll talk about specifically are chipset, bus, and lane. And no, although those words do have other meanings, I don't mean driving a bus on the lane on the highway. We're talking about these in electronics. We're also going to talk about parallel versus serial communication, which are two types of communication that occur in just about every type of electronics. And we're going to see this come up over and over again, not only when we're talking about motherboards, but when we get into networking as well. Once we do that, we're going to talk about chipsets in particular. Specifically, there are two manufacturers who make chipsets. There are two main chips that have been developed in these chipsets, the North Bridge and the South Bridge. We'll talk about the difference between those, and I'm going to point out now that these are really important and they will come up on the A+ exam, so you definitely want to pay attention, okay? We're also going to talk about the DMI, Direct Media Interface, which is what connects the North Bridge and the South Bridge together. Then we'll talk about buses, the front side bus or the hyper transport bus, which are just the same exact thing, the memory bus, and finally the expansion bus, which is where we'll leave off, and we'll discuss these two buses in more depth in later videos as well. Alright, so first let's discuss the word chipset. You've seen it probably in the objectives, and you've heard me talk about it. But really what a chipset is a group of integrated circuits or chips that are designed to work together and are usually marketed as a single product. So this is why when we have different types of motherboards, they have different chipsets, meaning the internals of them are the same. So although the motherboard, the spinal cord, is called the same thing on every human, it works differently. Perhaps from a human to a different type of animal that also has a spinal cord. You'll also notice physically these motherboards look very differently, and that's going to be something we're going to call a form factor. Form factor being the outside, the physical build of a motherboard. Okay? But what we're talking about here in chipset is the internal build of it. We'll talk more about form factors a little later, and that has a lot to do with chassis. A bus is one wire or a group of wires that carry data from one place to another. So very simply, just like a bus you drive, a computer bus is what carries data from one place to another, just like the cord that you plug in from your smartphone to your computer has buses on it. All right, but we're talking in terms of motherboard, something that's integrated onto the motherboard. And if we look really closely and zoom in on a motherboard, we'll see lots of these little circuits built on to the motherboard, and they're integrated. So I'm going to highlight a couple right here. I see one, right? And this is a circuit that's integrated onto the motherboard, allows communication, and here's another bus, okay? And there are several others here. And we can see them all over the place, and these are integrated right onto the board, and that's what allows the computer electronics to talk to one another. And you can see these all over the place, so I don't need to draw over every single one. But you get an idea of where these buses are and how ubiquitous they are on a motherboard. When we're talking about communication, electronic communication specifically, there are really two main types we're going to see over and over again, not just on a motherboard, but when we get to networking as well. The first is serial communication. Now, serial communication has to do with sending one bit of data at a time. If you pardon my not-so-straight lines here, that means that, just like this, I'm sending one piece of data at a time. So this piece of data right here has to arrive before, or has to be sent rather, before I can send this piece of data. So you can see there's a limit to how much data I can send at any one point. Now this is very different from parallel, which allows me to send multiple bits of data at a time. So I could send 4, let's say, bits of data, or 8. All right, now, one thing that's important to know here is that all of this data is traveling in the same direction. Okay, so this doesn't allow, serial or parallel doesn't differentiate between the direction the data is going, just how much data can be sent at any one time. Now, what's also important is you'll see here this word bit. All right, and you'll see it down here. Now, when I say bit in computers, we're not just talking about a very small amount. There's actually a mathematical amount that we're talking about. And what that is the difference between bits and bytes. This is probably something you've seen, but you're not even aware of. There are 8 bits in 1 byte. And you'll notice here that bits are represented by a lowercase b, whereas bytes are represented by an uppercase b. Okay, so 1 megabit per second is equivalent to 125 kilobytes per second. So that's why when you get your cable modem installed and they say, oh, you're going to get let's say 16 megabits per second transfer rate, and you get home and you're really only going to get 2 megabytes per second in transfer, right? And when we talk about storage and hard drives later, we deal with this big B, the megabytes. So that's where the confusion lies. So it's really important to differentiate between these. We'll come back to this number 8 again and again, especially when we get into networking. So it's really important to pay attention to that. Again, 8 bits in 1 byte. Also, something I want to point out just while we're here, as you see the M and the K, this all is math, right? So if I have 1 byte, that's 1 kilobyte would be 1,000 bytes. 1 megabyte would be 1,000 kilobytes. 1 gigabyte would be 1,000 megabytes, etc., etc., etc. All right. The last vocabulary word I want to talk about is lane. And what a lane is 2 serial wires that enable the sending and receiving of data simultaneously. So this means that now, instead of just sending over data and then having it sent back over the same cord, I can actually instead send data and receive data at the same time. So you can see how this is going to allow for a different type of communication. Okay. So we've now covered some vocabulary. We covered what a chipset was, base and lane, and we also talked about parallel versus serial communication with a little bit in there about bit versus byte. So, let's get into chipsets. There are 2 main chipset manufacturers, and when it comes to motherboards, I should say. And these are the same names you're going to see with central processing units, or CPUs, Intel and AMD. And what this means is not that they actually make the chip, right? You see Sony on some and Samsung on others. But what this means is they've come up with the chipset, the architecture of these motherboards, of these CPUs. So it's important to recognize these two. Now, when it comes to speed or quality, these are pretty much equal, right? There's really no difference here. There used to be arguments who is better, Intel or AMD, but nowadays that argument is we don't really hear it anymore. All right, so now let's get into this. Is a really important part of A+, is there are 2 main chips that control communication on a PC motherboard: the North Bridge and the South Bridge. The North Bridge, which is also called the Memory Controller Hub for a reason you'll see in a second, is responsible for high data transfer devices. So think about North, high, it's higher up. It's going to be responsible for high transfer devices. And there are 2 main high data transfer devices we're talking about here: high-speed graphics and memory, or RAM, which is random access memory. These 2 items need the fastest communication to the CPU, to the brain of the computer, the central processing unit. Now, this is different from the South Bridge, again, lower than the North Bridge, which is also called the I/O Controller Hub, or the ICH. And this is for secondary controllers, just about anything else, okay? So any input-out devices such as hard drives, USB, Ethernet, just about everything else is going to be controlled by South Bridge. So when you see North Bridge or South Bridge on the exam and it asks you what device is transferred over those, you want to remember that the only devices that are going to use the North Bridge are high-speed graphics and RAM. If you can remember this, it makes it very easy to answer any questions, okay? So again, high-speed graphics and RAM are controlled by the North Bridge. The South Bridge, everything else. That's what allows communication between everything else. And here is a diagram of the North Bridge and the South Bridge. You can see. Again, you can see that here's the you can see here I have graphics, and here's memory, the only two things connected directly to the North Bridge, as well as the CPU, which makes sense because it's the fastest required. It requires the fastest communication. And the South Bridge, just about everything else, right? So I got my onboard graphics controller, some other external buses, etc. We'll talk about what all these things mean a little later. We see this here as well, right? North Bridge PCI Express, which is a high-end graphics card we'll talk about. That connects to the North Bridge. RAM, North Bridge, everything else, South Bridge. The direct media interface is what connects the North Bridge and the South Bridge. So if we go back here, you see here, direct media interface. This is called the internal bus, but that's just another name for the direct media interface. This is what connects the North Bridge to the South Bridge. I just point this out so that if you see the term direct media interface on the test, you know that that's the thing that connects the North Bridge and the South Bridge together, these two main chips that control communication on our motherboard. So now we've talked about the chipset. We've talked about Intel versus AMD, our two main competitors and manufacturers. The North Bridge, again, responsible for RAM communication and high graphics, and the South Bridge, which is everything else, and the DMI, direct media interface, which connects the two together. So let's get into buses. So we see two different definitions here, front-side bus and hypertransport. And the only difference between these, they're exactly the same, is one is what Intel calls it, the other is what AMD calls it. Okay? And what the front-side bus is, the very front of that bus, right? What's the most important thing of our computer? The brain, right? And that's the CPU. So the front side bus is what allows the CPU to communicate with the North Bridge or with the rest of the motherboard. Okay, so that's the front side bus. It is that communication route between the North Bridge and the CPU, and between, in effect then, the South Bridge and the CPU as well. The memory bus also connects to, do you know what? That's right, the North Bridge, right? Because memory bus, right, again, is the fast speed that needs to go straight to that North Bridge, has a closer connection to the CPU over here. All right, so the memory bus is where all the RAM plugs in. We'll talk more about these memory slots that you see represented right here in a later video. Expansion buses are all the other buses that allow us to expand the capabilities of the motherboard. And if we go look at a motherboard real quickly, you can see several of these expansion buses here, right? So here's a couple. These are called PCI expansion buses, and here's an expansion bus. And then we have several expansion buses for storage devices here. And you can see a couple expansion buses, or devices rather, already plugged into expansion buses if you look right here. And the next video is what we're going to talk about are these specific expansion buses and the differences between them. All right, but before we get there, let's just recap what we've talked about. So we just talked about all the different buses: front side bus, hypertransport bus, memory bus, and expansion buses. So recap this entire video. We talked about certain vocabulary, chipset being all those chips put together and marketed as one, a set of chips, if you will. The bus, which transports data from one place to another. A lane, which allows for communication in and out. We talked about parallel versus serial communication. Parallel meaning more than one bit of data at a time, whereas serial is one bit of data at a time. We also talked about the chipsets, the two major manufacturers, Intel and AMD. The North Bridge, which again, I'm just going to write it up here again, allows the connection of RAM, or rather the communication of RAM, random access memory, and high-speed graphics. I just want to write that again because it's an easy way to remember this. You don't have to remember every single thing the South Bridge does. All you have to do is remember the North Bridge is responsible for RAM and graphics, and now you know exactly what the North Bridge and the South Bridge control. So We also talked about the South Bridge, which is everything else other than these two things, RAM and graphics. And the DMI, Direct Media Interface, which connects these two, the North Bridge and the South Bridge, together. We talked about buses, the front side bus, which is also called the Hypertransport bus on AMD, a memory bus, which communicates between the memory, the front side bus and Hypertransport bus, like their names, CPU communication, and finally, expansion buses, which allow us to expand the capabilities of our motherboard and plug other things into it. So, with all that being said, let's move on to the next video and talk about our expansion buses and the type of storage, the different technologies that go along with those, and the different types of storage technologies we have.